Alright, so we're done now with our making of the statement of the problem. We have specific questions, and the specific questions would refer to the descriptive statistics and the inferential statistics that we are going to use. So for descriptive question, we will use practically the mean in order to answer it. But in our inferential question, we are going to use inferential statistics. And for this session, we are going to talk about inferential statistics, particularly hypothesis testing. Now, take note of the previous video or the previous material that we sent you, the soft copy of the academic stress among junior high school students. And take note that there's an inferential question in that problem which says, is there a significant difference in the extent of academic stress among junior high school students when grouped according to sex, grade level, and section? And with this inferential question, we have this hypothesis. There is no significant difference in the extent of academic stress among junior high school students when grouped according to sex, grade level, and section. And once again, in this discussion, we're going to talk about what is hypothesis and how do we answer this hypothesis. So our objectives for this lesson, we have to learn how to state the null and alternative hypothesis, and probably do it in symbols, then state the 5 steps in hypothesis testing. So let's start with this question. What is a statistical hypothesis? So when you talk about statistical hypothesis, it means a conjecture or an assumption about a population parameter. This conjecture may be true or not true. There are 2 kinds of statistical hypothesis. We have first the null hypothesis, which is represented by H sub 0. It states that there is no difference between a parameter and a specific value or between 2 parameters. So it is usually the hypothesis that sample observations result to purely from chance. Then we have what we call the alternative hypothesis. It states the existence of a difference between a parameter and a specific value or between 2 parameters. It is denoted by symbol H sub 1, or in some books you can see it's H sub A. It is also the hypothesis that sample observations are influenced by some non-random cause. So the best way to determine whether a statistical hypothesis is true would be to examine the entire population. But that is very much impractical, and we as researchers would examine only a random sample from a population. And based from our hypothesis, we have to examine the sample data if they are consistent with our hypothesis. If not, then we will reject or not reject our hypothesis. But what do we reject? What do we not reject? So let's have the methods of hypothesis testing. Technically, there are 3. We have the traditional method, the p-value method, and the confidence interval method. For the purpose of our discussion, we will not anymore have the manual solving of the following methods, especially the part wherein we have to look at the normal curve and how to solve the areas under the curve. But we will do traditional method first. Our purpose is to derive from this method the 5 steps of hypothesis testing. So let's begin with the traditional way of doing hypothesis test. So let's say we have an example that a researcher wants to find out whether a new medicine will have side effects. He wants to do this by testing the pulse rate of patients. Will the pulse rate increase, decrease, or remain unchanged? The given mean pulse rate of the population under study is 85 beats per minute. And then state the null and alternative hypothesis of the situation. In this example, you will notice that the population mean was given, which is 85 beats per minute. And we are going to create a hypothesis based from the given problem. So in this case, we base our hypothesis from the population mean. And take note, the population mean is represented by the Greek letter mu, while the sample mean is represented by the x bar. So we said earlier that when we talk about null hypothesis, we denote it by h sub 0. And since the population mean is equal to 85, we can say that the null hypothesis, it says here that the population mean will be equal to 85 and will not differ. So that's our null hypothesis. For our alternative hypothesis, we can state it in three terms. The first one you see in green, we have there the mu, or the population mean, should not be or not equal to 85. Alright, so if you state that into hypothesis form, you can say that there is a difference, a significant difference between the sample mean and between a sample and then the population mean. Those that are written in yellow, as you can see, the symbol has changed from not equal to either less than or greater than. Now, the reason behind this, because hypothesis testing could be either two-tailed or one-tailed. So if you see equal and not equal, these are examples of two-tailed test, which means that the statistical hypothesis is within the region of rejection on both sides of the sampling distribution, which we will talk about later. And then, if you have a one-tailed test, it's either be greater than or less than, because the statistical hypothesis where the region of rejection is only on one side of the sampling distribution. But for now, we will only discuss up to the level of writing our hypothesis in terms of symbols. And we will have these examples for now for us to be aware that our hypothesis could be written as two-tailed and one-tailed. So again, if you talk about two-tailed test, you're using the symbols equal to and not equal to. And if it's a one-tailed test, you have greater than and less than symbols. Let's have another example. A researcher wants to know the effect of mobile games to children. He wants to test the attention span of pupils exposed to mobile games. The mean attention span of the population under study is 20 minutes. State the hypothesis for this situation. You may pause the video and think about the given hypothesis and the given population mean, and then going back to the example before this, write the hypothesis in symbols. So in this example, you might notice again that the population mean is given. But what about if the mean of the population is not given and you need to compare two sample means, like what we have in our inferential question, which says there is no significant difference in the extent of academic stress among junior high school students when grouped according to letter A, you have sex, which means that one sample mean for male, one sample mean for female. Same is true with grade level, because we have 4 sample means for each grade level, and also we have for section. And this is what we're going to talk about on the next video. So stay tuned and please watch the next